lecture we are discussing about unit and conversion. We have a two type of unit. The first is fundamental unit and the second is derived unit. The fundamental quantity is a independent physical quantity that is not possible to express in other physical quantity. It is used as a pillar for a quantity asked derived quantity. In physics, length, mass, time, electric current, thermodynamic temperature, etc. are the fundamental quantity. The second one is derived quantity. The derived quantity is derived from fundamental unit. The derived quantity are quantity that are calculated from two or more measurement. Derived quantity cannot be measured directly. We have seven fundamental quantity named as length, mass, time, temperature, electric current, amount of substances, and luminous intensity. These are the some of the derived quantity and its unit. The unit of area is meter square. The unit of volume is meter cube. The unit of density is kg per meter cube. The unit of velocity is meter per second. And the unit of momentum is kg meter per second. The unit of acceleration is meter per second square. The unit of force is kg meter per second square or Newton. The unit of pressure is Newton per meter square. These are some of the basic unit conversion that we have to remember for exam purpose. The main aim of this topic is how to find the dimension of a derived quantity. We have some of the method to find the dimension of a derived quantity. The first method is a bidimensional analysis. Generally, we have a two method of dimensional analysis. The first is Raleigh's method. This method is used for determine the dimension of a quantity which depend upon the less than three variables. Let x is a variable which depend upon x1, x2 and x3. Then we can write x as a function of x1, x2 and x3 as x equal to f of x1 to the power a into x2 to the power b into x3 to the power c, or x equal to k times x1 to the power a, x2 to the power b and x3 to the power c, where k, a, b, c are constant. Now we have to equate dimension of LHS and RHS. Then we can find the value of ABC. The value of K can be determined experimentally. Then we can find the dimension of X. This is a quick problem regarding Raleigh's method. The time period T in a pendulum depends upon the length L of the pendulum and the acceleration due to gravity G. Then find the expression of the time period. So we can assume as a t as a function of L and G. So can write t equal to k times L to the power a into G to the power b. But then G we can write L, that dimension of L as m, and the dimension of G is the dimension of acceleration. So dimension of G is the meter per second square. We can equate the dimension in the both side to find the a and b, and the value of k is determined experimentally through through this two equation we can find a and b, and then now find the dimension of t. The second method is Buckingham method. Actually, this method is used to determine the dimension of a quantity which depend upon more than three variables. We have n number of variables. Then this variable contain m number of fundamental dimensions. Then n can be arranged to n minus m number of dimensionless group. This dimensionless group is called pi term. Each pi term contain m plus n number of variables, and out of these m number of variables are repeating in all pi terms. These are the all about the unit and conversion. Thank you.